Hey everybody, here is some discussion and talk about 10.6 where we talk about this word secant. We're going to add that to our circle party here. A secant is just a line that intersects a circle at exactly 2 points. You know, sometimes it's tangent to the circle, sometimes it just goes right through the circle and intersects at 2 points. But what that creates when you have secants in a circle, all of a sudden it creates some angles and some arcs and all kinds of cool stuff. But keep in mind, you can't ever assume that this is a central angle. Sometimes it's tempting, so be really mindful of that. So a couple theorems that they talked about in this section, hopefully you read through them, is to find the measure of an angle that is created by this intersection of two secants. You need to take 1/2 of the sum of the arcs that are intersected. So like angle 1 here intersects, if you can see that angle 1 here intersects arc AB, and angle, basically thinking about vertical angles, also intersects arc CD. You add those together and take 1/2 of that sum. And we're going to go through a couple examples over here, actually. Let's go look at this. So over here, we've got two secants, AD and BE, that intersect at this point C, and we need to find the measure of angle X here, this angle measure. So I know the measure of this angle is 1/2 the sum of 48 plus 182, which will give you 230. So you have 1/2 times 230, and so your angle measure is going to be 115 degrees. So your X is going to be 115 degrees in that one. Now if you look at this next example, we're given this angle measure, but we need to find an arc length. So now I know I have this equation of 110 equals 1/2 this arc length X plus 92. And I would multiply both sides by 2 to get rid of that 1/2. So you get 220 equals X plus 92, subtract your 92, and you will be left with 128 for your X. So your X right here is 128 degrees. So process that for a moment, digest, and then I want you to look over here. So when we have a secant right here, there's two secants. One just they happen to meet here at this point of tangency. So it creates these two supplementary angles, if you can see that. And basically, if you're trying to find the measure of angle 1 here, it is 1/2 of the length of this angle, or this arc AB that it intersects. And if you look at angle 2, find another color. So angle 2 is going to be 1/2 the length right here of arc BCA. So hopefully you can see that, and then I've got one more example over here to look at. So we have this angle HJK, and notice this point of tangency is also where two secants meet. So if we have to find the measure of arc JLK, I know here that 116 is 1/2 the arc length of JLK. So if I double that, I will get that this arc length is, so arc length of JLK, the measure of it, is going to be 232. So we've got 232 degrees right here. So that's interesting. And now if we want to find the measure of arc JK, a couple ways you can do it. You can do your 360 minus your 232, or you could find this supplement and apply the same thought. So 180 minus 116, we know this angle measure is going to be 64. So we would have 64 equals 1/2 that arc length of JK. Sorry about my writing. So we would know that JK is now equal to 128. Or you could have also done 360 minus your 232. So there you have it. That is a lot of stuff that is in, oh actually, hold on. There's one more thing to talk about in this section. So if you look at this, sometimes your secants meet at a point outside the circle, and sometimes they'll cross right through. One might be at a point of tangency, one might cross right through, but they also might just be at points of tangency. To find the measure of those angles, then what you're going to do, instead of finding the sum, which we did earlier, Notice the point where they met was inside the circle. We found the sum, and then we averaged it or divided by 2. Now, when they intersect on the outside of this circle, what you're going to do is you're going to subtract. You're going to find the difference of these two arc lengths and then divide it by 2 or take 1/2 of it. So it's just a little bit of a different thought, and I do have one more example if you would like to look at it over here. So here we've got this point of tangents, or this point where the secants meet outside the circle. So I know to find the measure of angle C, I take, whoops, that's a C, equals 1/2 times the difference of 200 minus your 66. And when you do your 200 minus, sorry, I'm looking at something. Their measure of angle C is now 1/2 of 134. And then you take 1/2 of that, and you will end up with 67 degrees for your measure of angle C. So hopefully that helps with section 10.6 in our book. Have a good day.